Rightio. We've got y is equal to x dy dx plus the exponential raised to the power of the derivative of y. So to solve this, we'll differentiate both sides. Left-hand side, we'll get dy dx, nice and simple. Right-hand side, for the first term, we'll use the product rule. Holding the x still, we'll get x multiplied by d2y dx squared. And holding the dy dx still, the x will disappear, so does dy dx. The exponential term then, will differentiate the power and bring that to the front. So d2y dx squared. And then we'll rewrite the original thing. So e to the power dy dx. First thing to notice, the two dy dx's, they will cancel out with each other. Lovely jubbly. And then every other term has a second derivative of y in there. So we can factorise that out. We'll have d2y dx squared multiplied by x plus e to the power of dy dx. And that whole thing equals 0. So straight away, we can have the solutions where like the second differential is 0. So that tells us that every linear function, every straight line, is going to be a solution to our equation. Spot on. Looking at the other bracket then, when that equals 0, what we can actually do is first of all replace our e to the power of dy dx. If we rewrite our original equation, we know that e to the power of dy dx is equal to y minus x dy dx. So we'll sub that in and rewrite the stuff. We'll have x plus y minus x multiplied by dy dx. And that equals 0. We can rearrange a little bit then. We'll try and make the dy dx positive, and we'll bring the y with it as well. So we'll have x dy dx minus y is equal to x. And what we'll do now is we'll divide by x everywhere, so the dy dx is just by itself. The reason we're doing this is so that we can use the integrating factor. So we know our integrating factor is going to be whatever is like left in the term with y apart from the y. But not just that thing, but e to the power of the integral of that thing. So integral of minus 1 on x, and differentiated with respect to x. This will give us e to the power of negative log of x. And using our log laws, altogether, this is going to give us 1 on x. So what we do now, we multiply through everywhere on our original equation by 1 on x. So we'll have 1 on x dy dx minus y on x squared is equal to 1 on x. And now this left-hand side is going to be the derivative of y on x. And that whole thing is equal to 1 on x still. And now then, we can integrate both sides. On the left, we'll have y on x. And on the right, we'll have the natural log of x. And we'll add a little constant in. So multiplying by x to get y by itself, y is equal to x log x plus some constant times by x. Spot on. So two solutions, one over here, and a straight line as well on the left-hand side.